This is a demo video to go alongside my dissertation project for the Creative Technologies project. The project title is Artificial Intelligence in a Procedurally Generated World, and this video will go through how to use the application and show off a few examples of different scenarios. The world that you can see here is generated using Perlin noise with the current position as the seed. The Perlin noise has a series of octaves with different frequencies and amplitudes, along with cosine interpolation between gradient vectors, to attempt to produce the most organic look and variance for the terrain. By moving the mouse to the bottom of the screen, you can bring up the configuration menu. Here you can find some options for the agent behavior, basic commands, and information about the current state. Mountaineer, amphibian, and prefers grass options all change how the agent values the different environment grid locations, whereas the stay on contours option changes how the agent chooses its path, which overrides the three other behavioral options. In the center is a toggle button, which alternates between placing goal nodes and placing blocks in the world. This corresponds to what the mouse button click does in the world when a grid location is clicked on in the view. To the right we have information about the current state, probably the most notable being the current cost of the path at the bottom of the list. And finally, we have a button for generating a new world seed. Here is an example of the agent moving around some water with the prefers grass configuration option selected. Notice how when I selected the amphibian option and place the new goal node on the other side of the pond, the agent changes the nature of its path. This is because the prefers grass option causes all of the grass tiles to cost less than the water tiles, and the amphibian option does the opposite. Here you can see the agent descend a mountain and reascend again to reach its goal node, but it makes much more sense for the agent to stay on the mountain contours if its goal node is on an elevated position anyway. If I select the stay on contours option and replace the goal node, you can see that the agent stays on the contours and doesn't needlessly descend. Here is an example of the blocks being placed in a mountain pass, causing the agent to route around the blocks, having to take a more costly route, as all nodes that have blocks placed on them are disregarded by the pathfinding algorithm. An additional option that has been introduced to the application is the pheromone button. This overrides the goal node and blocker button while selected, and allows the user to place pheromones in the environment. Here you can see the agent move on the grass area when the prefers grass option is selected. However, if I place some pheromones on the shallow water patch and replace the goal node, you can see the agent pass between the pheromones as it is attracted to them. Note, however, that the agent will not respond to pheromones if the stay on contours option is selected.